Hello everyone, in this video let's discuss about the traveling salesman problem using brute force method. If you are new to our channel, please subscribe for more engineering related topics. So in traveling salesman, in engineering perspective, we have three types. One is traveling salesman problem, solving it using brute force method. Second is solving using the dynamic programming method. Third is approximate traveling salesman problems. In approximate traveling salesman problem, two types, nearest neighbor and twice around the tree. So we will follow the step, that is first let's discuss about brute force method. In next video dynamic method. Next in last two videos we will be discussing about twice around the tree and nearest neighbor. So how to solve the problem of the traveling salesman using brute force method. So what traveling salesman problem says is, a man or a traveling salesman starts from a source. He will start from source. So source may be his home or a hometown. Let us consider it as P. If he starts from P, after evening, what the salesman will do? He will come to his home. That is, he must come back to his home, start from source and come back to source. Come back to source. So what is the condition? He must travel all the nodes or all the cities with the least cost. He must travel all the cities with least cost. Travel all cities with least cost. For example, if he starts at P, he must go to all other cities, that is Q, R and S, and return back to his source city, that is P, with the least cost. That is, he must travel to all the other three and come back to his source with the least cost. So how? Let's find out. First, to solve using the brute force method, draw the matrix. Draw the matrix. What are all the vertices or the nodes are here? P, Q, R, S. P, Q, R, S. P, Q, R, S. Now, from P to Q, what is the value or the cost? From P to Q, it is 3. From P to Q, it is 3. From P to P, therefore there is no self loop. You can write 0. Next, P to R, it is 6. P to S, it is 8. P to S, it is 8. Now, Q to P. Q to P, it is 3. Q to Q, no self loop, so 0. Q to R, it is 9. Q to S, it is 4. Next, R. R to P, it is 6. R to Q, it is 9. R to R, so no self loop, 0. R to S, it is 2. S to P, it is 8. S to Q, it is 4. S to R, it is 2. S to S, it is 0 because of the self loop. Now after writing the matrix and filling the values, let's find out the cost. Let's find out the cost. Finding the least cost. So now what will be the process? So we must travel through all possible ways. I will tell the short trick to solve the problem, because this will be a confusion for the students. So how to write all the possibilities? So I will share a short trick. First, what is the source node we took? Source node we took is P. So P will be the constant. Write 2 times P. Now, what are the 3 other nodes left? Q, R and S. Take one at a time. Now let's take Q. So P to Q, P to Q. What are the 2 other nodes left after Q? R and S. Right? Vice versa. That is R to S, S to R. Now I said if he starts from the source, he must come back to source. So source is P, so he will come back to P. So these are the possible two ways. Next, P and P will be common because P is the source. Now we used Q. It's over. Now in R and S, you can use R or S. Let's use R. From P to R, from P to R. Now you are left with 2. P and R is over. Q and S is there. So you must write vice versa of Q and S. Q to S, S to Q. So you will come back to his source node again. Next only left is Q is over, R is over. Yes. Now after P and S, what are left? R and Q. Right, vice versa. R to Q, Q to R. After that they will come to its own city or the source node. Now calculate the total cost. See, from P to Q it is 3. P to Q it is 3. Next Q to R. Q to R. Q to R it is 9. Plus R to S. R to S it is 2. S to P. S to P it is 8. Next P to Q it is 3. Plus Q to S. Q to S it is 4. Plus S to R it is 2. Plus R to P it is 6. P to R. P to R it is 6. R to Q it is 9. Q to S it is 4. S to P it is 8. P to R it is 6. R to S it is 2. S to Q. S to Q it is 4. Q to P it is 3. P to S it is 8. S to R 2. R to Q 9. Q to P 3. P to S 8. S to Q 4. Q to R 9. R to P it's 6. Now calculate. 9 plus 3 12. 12 plus 2 14. 14 plus 8. So now calculate. 9 plus 3 is 11. 11 plus 2 is 13. 13 plus 8 is 21. Next 4 plus 3 is 7. 7 plus 2 is 9. 9 plus 6 is 15. 9 plus 6 is 15. 15 plus 4 is 19. 19 plus 8 is 27. Next P 6 to next 6 plus 2 is 8. 8 plus 4 is 12. 12 plus 3 is 15. 8 plus 2 is 10. 10 plus 9 is 19. 19 plus 3 is 21. 8 plus 4 is 12. 12 plus 9 is 21. 21 plus 6 is 27. So if you see all the possible 6 paths through which a traveling salesman can move and come back to his city, the least cost is 15. It is here also, it is here also. Therefore, you can use the path P to Q, Q to S, S to R and R to P, or P to R, R to S, S to Q and Q to P. So these two will be the possible answer. You can use any one of them between these two. Hope you understood the concept of the traveling salesman problem. If you like the video, please subscribe for more engineering related topics and support us. Thank you.